Hello, I'm Natasha Gaskin-Peters. I have a PhD in economics and I'm a senior business specialist at the Center for Local Business Development, where I regularly teach the oil and gas industry course. In our last session, Section 1, I took you through an introduction to offshore oil and gas, its history, and give you basic information about both onshore and offshore operations. This session, Section 2, is an introduction to an offshore project's life cycle, zooming in on the exploration phase. First, let's look in detail at the typical project's life cycle in the offshore oil and gas industry. As we go through the material, you will gain a better understanding of the oil and gas value chain, a typical project's life cycle, and opportunities for your business. The oil and gas value chain has three main segments: upstream, midstream, and downstream. Upstream refers to activities related to the discovery of hydrocarbons. Hydrocarbons are compounds of hydrogen and carbon, which are the chief components of petroleum and natural gas. Midstream refers to activities related to the transportation and storage of oil and natural gas before processing begins. Downstream refers to activities related to processing oil and gas, as well as marketing and retailing of finished products. For example, selling fuel at gas stations. The offshore oil and gas activities in Guyana are in the upstream segment. However, the downstream segment has been evident in Guyana for many years through the business activities of retailers. This course is focused on the upstream segment of the value chain. An upstream offshore project life cycle involves three main phases: exploration, which can range anywhere from 5 to 10 years, development ranging from 1 to 5 years, and production 15 to 30 years. Exploration involves all of the activities needed in order to locate oil and gas reserves, and these include technical surveys by geologists, exploration drilling, appraisal drilling, and commercial analysis. Exploration ranges from 1 to 10 years and involves all activities to find hydrocarbons. Searching for oil and gas is a high-risk business activity, and despite the cutting-edge technology employed, millions of dollars are invested with limited certainty of success. Seismic surveys simply provide geophysicists with an image of the sediment and composition of materials under the seabed. If a survey is successful and there are positive indicators of hydrocarbons, exploration wells are drilled to verify that these are in fact hydrocarbon reserves. Exploration drilling is also necessary to verify the scale of the reserves. It may take several exploratory drilling wells to find a reserve. Drilling is a key aspect, but does not guarantee any returns on the investment in exploration activities. Exploration is all about information. The more information, the lower the risk. However, the techniques and equipment that get the most valuable information require a big budget, which pushes up the investment cost. Conducting seismic surveys is the first step to locate hydrocarbons. These are organic compounds made up of hydrogen and carbon atoms that are found only in crude oil and natural gas. The main objective of seismic exploration are to obtain an image of the subsurface, to locate the prospects and to propose exploratory drilling and well locations. The data is collected, processed, and interpreted specifically to characterize the geology of the area, determine where and at what depth hydrocarbons are present offshore, and to identify prospects for future drilling if there are positive indications of hydrocarbons. The two main types of seismic surveys are two-dimensional images or 2D and three-dimensional images or 3D. The more advanced surveys give more precise information about the location and presence of hydrocarbons. 2D is a single line of data which is recorded and enables only a limited evaluation of a single slice of Earth. In the 3D seismic data, there are multiple parallel lines of data. This is then processed to create a 3D image of the subsurface. There are also other types of seismic surveys, such as four-dimensional images or 4D and multi-azimuth. To further understand the seismic survey process, you can click on the link provided. Seismic surveys use a technique similar to ultrasound scans for medical imaging. They provide geoscientists with a picture of the subsurface and its composition. From that analysis, geoscientists can determine the location of hydrocarbons. As you can see, conducting these surveys requires advanced technology and specialized knowledge to interpret the information and make decisions on drilling locations. It can take several months to complete seismic surveys and get the most accurate results. If seismic surveys get positive results, a company may decide to drill an exploration well. At this stage, both the costs and the financial risk increase considerably. The objective of exploration drilling is to confirm or refute the hypothesis that hydrocarbons are present. Oil versus no oil. An exploration well gathers additional necessary data for a better understanding of the area and its possible future production output. Geologists conduct direct observation from rock samples such as cutting and cores taken during the drilling of the well. Drilling a well can take about 1 to 6 months and is very risky, with the probability of success sometimes as low as 20% and less in frontier basins. The key asset is a drilling rig. For deep offshore exploration, drill ships and semi-submersibles are most commonly used. A few data collection methods applied while drilling an exploratory well include coring, a method of collecting rock samples, wireline logging, lowering an electrical cable into a wellbore and using it to transmit data about subsurface conditions, LWD or log while drilling, measuring the properties of a geographic formation before drilling fluids invade. As the exploratory well is being drilled, it is constantly evaluated to determine if there is enough oil and natural gas in the reservoir to make it commercially viable. To better understand this process, let's take a closer look at what is involved in offshore drilling. To view this video, click on the link provided. Once exploration drilling confirms the presence of hydrocarbons, appraisal wells are drilled to gather additional information regarding the commercial viability of the reservoir. This gives us an idea of how much oil is located in the area. Appraisal drilling also reduces uncertainty about the characteristics and properties of the hydrocarbons present in the field. This helps to assess costs and the best methods of extraction. Appraisals may take several years and are very costly. but they are very important in production decisions. Various tests are performed on the wells to establish reservoir performance, reservoir thickness and variation across the structure, porosity and permeability, flow characteristics, and fluid content. Once these properties are known and analyzed, 3D models are built to help make drilling decisions. Appraisal drilling is a pivotal part of the exploration phase because it provides vital information about the viability of specific wells. This enables investors to decide whether or not it is worthwhile to proceed to the production phase. Now that we've looked at the 3 exploration activities, seismic surveys, exploration drilling, and appraisal drilling, let's bring together the core concepts from exploration. The exploration phase comprises all the activities companies undertake to find hydrocarbons, oil and gas. Searching for oil and gas is a high-risk business activity. Despite cutting-edge technology employed, millions of dollars are invested without a high certainty of success. Exploration wells are essential at this stage to discover and confirm the presence of new hydrocarbon reserves. Wells are expensive, and a company may drill and not find anything. Exploration is all about information. The more information, the lower the risk. However, obtaining the most valuable information requires greater investment, especially in advanced seismic surveys and surveying through exploration drilling. In the graphs depicted, we can see the onshore costs of exploration are also costly, but significantly lower in comparison to the costs of offshore exploration. This is so because offshore exploration comes at a greater risk, and obtaining accurate information is expensive with no guarantees of commercial returns. Companies are recruited to do the exploration phase by direct contract. They are primarily the provision of services at this stage and not the purchase of goods. But each of the services listed here is supported by a vast range of indirect services supplied onshore, such as catering, security, waste management, water provision, ICT services, recruitment services, maintenance of facilities. The oil and gas value chain comprises upstream, midstream, and downstream. We also learned about the offshore oil and gas upstream project lifecycle. Additionally, we learned about the exploration phase activities and their importance, which include seismic surveys, exploration drilling, appraisal drilling, all activities involved in the exploration services, and how and where local companies can fit in.
This section covered a lot, Natasha, especially now that we are starting to look up close at the project life cycle. In this part of the course, participants often ask, where is the Guyanese offshore industry in the oil and gas value chain today?
This is a great question, Cara, and one that often needs clarification. Today, Guyana's offshore industry is in the upstream segment of the oil and gas value chain. It currently has exploration and development project phases of the upstream segment, but the country has not yet moved into the production phase. So we have an incomplete upstream segment at the moment until 2020, when production for Guyana's first oil offshore project, the Liza 1, is expected to start. Guyana has no midstream segment, but a partial downstream segment exists in the form of the petrol stations.
And what again are the core exploration activities?
The core exploration activities include seismic surveys, exploration drilling, and appraisal drilling.
I see. Now a question on the minds of many who are active in the center's activities and from the Guyanese business community in general is, what are the contracting opportunities for my business in the exploration phase of an offshore project? How do you typically explain this, Natasha?
At the exploration stage, contracting opportunities for local businesses are few, as these services are highly specialized and require advanced technology.
You mentioned earlier that exploration is risky. Why is the exploration phase risky in this industry?
This is an excellent question, Cara, and one that is often asked. The industry probability of finding oil offshore is less than 20%. Additionally, the costs at this stage are very high, with no guarantee of discovering a reservoir. No one wants to encounter a dry hole in their exploration activities. When a dry hole is encountered, this means that no oil was discovered at the site. In this case, the cost may not be recoverable, and regardless, the oil and gas companies would have to bear the cost. Remember that you can review this section at any time, and if you have additional questions, please post them to the course forum where they will be addressed by the CLBD. You can also visit our website at clbdguyana.com to sign up on the supplier registration portal and find updates on our course offerings. In the next section, we will look at the phase after exploration in the upstream offshore project lifecycle, that is, development. I'm Natasha Gaskin-Peters. See you in my next class as we continue to explore the oil and gas industry in Guyana.